Imagine stepping onto a spaceship, strapping in, and moments later you're traveling to another star system, not in thousands of years, but in just a few weeks. No cryosleep, no generation ships, just pure faster-than-light travel. Sounds impossible, right? After all, Einstein's theory of relativity says that nothing can travel faster than light. And as far as we know, breaking this universal speed limit is impossible, unless we find a way around it. That's where warp drives come in. For decades, physicists have explored a radical idea. What if we didn't need to move through space at all? What if we could bend space itself, compressing it in front of us and expanding it behind us so that instead of moving, the universe moves around us? This isn't just science fiction anymore. The idea of a warp drive was first proposed in 1994 by physicist Miguel Alcubierre. And since then, researchers, including some at NASA, have been trying to figure out if it could actually work. So could warp drives turn interstellar travel into reality? What are the biggest challenges? And if we actually built one, how would it change the future of humanity? Welcome to Infinitia Verity, where we break down the most mind-blowing concepts in science and technology. Today we're exploring warp drives, space-time distortions, and the future of interstellar exploration. Buckle up, this is going to be a wild ride. Before we talk about warp drives, let's address the problem they're trying to solve: the ultimate speed limit of the universe. Einstein's theory of relativity tells us that nothing with mass can travel faster than light. But why? Because as an object moves faster, its mass effectively increases. The closer you get to light speed, 299,792,458 meters per second, the more energy is needed to keep accelerating. If you were to reach light speed, you'd need infinite energy, which obviously is impossible. Another problem? Time slows down the faster you go. This is known as time dilation, an effect already proven in physics experiments. Example: astronauts on the International Space Station experience time slightly slower than people on Earth due to their high orbital speed. At speeds close to light, time dilation becomes extreme. A journey that feels like 10 years for a traveler could mean centuries have passed on Earth. Even at 99.9% the speed of light, it would still take over 4 years to reach Proxima Centauri, our nearest star. To reach other star systems, thousands or even millions of years. That's why science fiction often turns to hyperspace, wormholes or warp drives, anything to skip past this limitation. So, if we can't travel faster than light, can we bend the rules instead? Could we move through space without actually moving? That's where warp drives come in. In 1994, physicist Miguel Alcubierre proposed something groundbreaking. What if, instead of trying to break the speed of light, we just move space itself? Instead of pushing a ship through space, what if space-time could be compressed in front of the ship and expanded behind it? This would create a warp bubble, a pocket of normal space where the ship remains stationary while the universe itself moves around it. Since relativity doesn't limit how fast space-time itself can expand or contract, this could allow travel faster than light without actually violating physics. Imagine you're standing on a moving walkway at an airport. Instead of walking faster, the walkway itself moves you forward. Now scale that up to cosmic proportions. The ship generates a warp bubble around itself. Space-time contracts in front of the ship, bringing the destination closer. Space-time expands behind the ship, pushing it forward. Inside the bubble, the ship and its passengers feel zero acceleration, meaning no crushing G-forces. In theory, you could travel vast distances in space without actually moving, and that means you wouldn't be limited by the speed of light. The equations for a warp drive actually work in Einstein's field equations, but there's one major issue: it requires exotic matter. Exotic matter is a hypothetical substance with negative energy density, something we haven't yet observed in nature. Early estimates suggested a warp drive would need as much energy as the mass of Jupiter. However, recent refinements suggest that we might be able to reduce this energy requirement significantly. So is warp drive just a beautiful mathematical concept, or could we actually build one? Before we answer that, let's talk about the biggest challenges. So, if the math works, why don't we have warp drives yet? The truth is, there are some massive obstacles standing in the way. Early calculations suggested that a warp drive would require more energy than the entire mass of Jupiter converted into pure energy. That's more energy than all of human civilization could generate in 1,000,000 years. However, recent studies suggest we could dramatically reduce this requirement by changing the shape of the warp bubble. Even so, we'd still need an energy source far beyond anything we have today. Warp drives rely on exotic matter with negative energy density, something we've never observed in nature. Quantum physics suggests negative energy might be possible, but we have no way to create or harness it yet. One possible candidate is the Casimir effect, where quantum fluctuations create negative energy in a vacuum. Could future breakthroughs in quantum physics unlock the key to warp travel? Maybe, but right now it remains theoretical. Even if we somehow created a warp bubble, we have no idea how to stabilize it. Some models suggest that once activated, the warp bubble could collapse instantly or move unpredictably. If we can't control where we go, a warp drive isn't much use. Imagine hitting the go button and instantly warping into a black hole. Yeah, not ideal. Some theories suggest a warp drive could allow for closed time loops, meaning you could arrive before you even left. If time travel is possible, it could create paradoxes like the famous kill your grandfather problem. Some physicists believe nature prevents paradoxes, while others think it's possible under certain conditions. So, does this mean warp drives are impossible? Not necessarily. In fact, new research suggests we might be closer than we think. Believe it or not, scientists are actually studying warp drives right now. While we're nowhere near building one, we've made some surprising discoveries that could one day make them possible. NASA physicist Dr. Harold White has been researching ways to manipulate space-time at small scales. His work suggests that by modifying the shape of the warp bubble, energy requirements could be reduced significantly, from the mass of Jupiter to something more reasonable like a large asteroid. NASA has even conducted small-scale experiments to test space-time distortions, though results remain inconclusive. The fact that NASA is taking warp drives seriously means we might be onto something big. In 2021, physicist Eric Lentz proposed a new warp drive model that could, in theory, work without exotic matter. Instead, his design uses classic physics principles and high-energy fields to create a warp bubble. If his theory holds up, it would remove one of the biggest roadblocks to warp travel. This could be a game-changer if we can prove it experimentally. Defense agencies and private space firms are funding exotic propulsion research, including concepts related to space-time manipulation. While most of these projects are classified, some believe warp technology might already be under early investigation. Are we secretly working on warp drives? Probably not yet, but scientists are taking the first steps toward making it a reality. Let's imagine that somehow we crack the code, we solve the energy problem, stabilize the warp bubble, and build the first working warp drive. What would that mean for humanity? With a warp drive, we could travel between stars in days or weeks instead of thousands of years. The nearest star system, Proxima Centauri, is 4.2 light-years away. With a warp drive, it could be a weekend trip. Instead of struggling to explore our own solar system, we could reach hundreds of new worlds. Mars, a warp drive could make it feel like a short commute. Humanity would no longer be limited to Earth. We could colonize habitable exoplanets, ensuring the survival of our species. The first true space civilizations could emerge, shaping the future of humanity. The dream of becoming an interstellar species wouldn't just be possible, it would be inevitable. If intelligent extraterrestrials exist, warp technology could let us finally reach them. Some scientists believe that if aliens are out there, they're likely already using advanced propulsion systems like warp travel. Could faster-than-light travel be what finally leads us to a real first contact moment? Would we find new allies or new rivals in the galaxy? That's a question only warp travel could answer. Understanding warp drives means unlocking deep secrets of the universe. It could lead to breakthroughs in quantum mechanics, gravity, and space-time manipulation. Warp technology wouldn't just take us to the stars, it could redefine the very nature of physics. So, will warp drives ever leave the realm of science fiction? That's the real question. So where do we stand? Are warp drives science fiction or the future of space travel? The theory works. The math behind warp bubbles is solid, and Einstein's equations allow for space-time distortions. The engineering is the real challenge. Right now we have no way to create or control a warp bubble. Energy and materials are the biggest roadblocks. Until we discover exotic matter or an alternative way to power the drive, warp travel remains out of reach. but progress is happening. Scientists are actively working on space-time manipulation, energy field theories, and ways to reduce the energy needed for a warp drive. We might not be there yet, but every breakthrough in physics brings us closer. Will warp drives become reality in 10 years? No, in 100 years. Maybe in 500 years. Who knows? If humanity survives long enough, the idea of interstellar travel may one day shift from impossible to inevitable. What do you think? Are warp drives the future, or will we always be stuck in our own solar system? Drop your thoughts in the comments, and if you love deep dive science explained in a way that makes sense, don't forget to like, subscribe, and hit that notification bell. We have more mind-blowing discoveries coming your way. This is Infinitia Verity, where science meets the impossible. See you next time.